welcome to the next JAX London 2020 session. I'm here with Martijn Verburg. Hi, Martijn.
Hello.
Great to be here with you. I think I'm basically just going to tell everyone, hey, you know by now probably, but don't forget we've got the chat to ask the questions if that's what you'd like to do, or get stuck into chatting with each other. And yeah, I think with that, I will hand Martijn the floor. So please.
Cool. Good morning, good afternoon, good evening, wherever you might be in the world. I'm presenting to you actually from London. Yes, one of the few presenters who has actually managed to make it to London because, well, I live here. So welcome to the session for, oops, let me just forward slide here. Yep, modern Java for cloud developers. I'm just going to mute because I'm sitting on, oh, let's have a look here. I just need to mute a tab here because I've got the Q&A running. There we go, that's better. Right, off we go. Sorry about that. Hi, yeah, my name is Martijn Verburg. Some of you will have known me in previous years as the diabolical developer and the former CEO of jClarity. But something changed last year. Microsoft came and acquired jClarity and acquired myself and the whole team in kit and caboodle, as we like to say here in the UK. And so now I'm the principal group manager for Java at Microsoft. Yes, you heard that right, Microsoft. Strange bedfellows indeed, but I'll cover some of that in today's talk. You can see my Twitter handle there, and if you want to follow the Java at Microsoft Twitter as well, you can see there it's Java at Microsoft. We already have several thousand followers, and we're producing some pretty amazing content there, so please do go check it out. Yes, Microsoft and Java. I know, it seems weird. It was one of the things that I said, I think 7 or 8 years ago, that, you know, Microsoft was a company I would never, ever work for. But here Duke is, riding the mighty Microsoft dinosaur, and they're both collecting garbage along the way and helping you run your applications. Very cool. So what I'm going to cover for you today, we're going to quickly cover some metadata. I'm going to then cover off some of the advancements that have happened in Java recently. I appreciate most of the audience is probably still running Java 8, or if you're lucky, Java 11. But there really are some advancements beyond Java 11 that you will want to consider taking into account as you move either to cloud workloads or building new workloads in cloud environments. I'll cover how some of those advancements that Java has. I'll quickly cover the popular microservice frameworks and talk to you a little bit about the choice you have there. And then I've had a request from numerous people at numerous conferences. What the heck is going on with Microsoft? Why are they investing in Java? We want to know what's going on. So I'll just cover that for a little bit. And you'll note in the italicized bit at the bottom, there's a little bit of marketing stuff, which I'll probably skip because this is JAX London. Right, so on to metadata. So first of all, I just wanted to thank everyone for taking the time to come to JAX London, the virtual edition. It's obviously a challenging time for all of us in the world today, and it's especially challenging when you're a conference goer and you really miss that mingling with people in person, being able to like pull the speaker to one side and ask the questions, and of course enjoy the wonderful food that is put on for you. So there's going to be a few differences in this talk to what you're typically used to. There's more text, right? Because you're sitting there passively in the virtual audience. You have a little bit more time to absorb the written text. But what I'll be focusing on is just trying to give you some context behind the words. So please do listen out. If you have a pen and paper or a note-taking system, there may be some interesting tidbits that you may want to note down as well. And of course, there's Q&A. Now for the Q&A, you can feel free to fire questions as I go. I will sort of pause after each section, and I'll do my best to answer any questions you may have. And of course, there's sort of a 10-minute period at the very end as well. Rightio, so let's get into the modern Java. So, the tech media would have you believe that Java is dead. And this mantra gets repeated year after year, and we've been fighting it for a very long time now. You notice here the dead parrot, for those of you who are Monty Python fans. But the reality is actually very, very different. And I can talk to some numbers and some things going on in the ecosystem to demonstrate that. So let's cover that first of all. Here's a little pop quiz, and I should actually put this in the poll in the good old swap card system as well. How old do you think these top 3 languages are? So I'll give people 30 seconds or so to answer this. In fact, I may even just produce a poll on the fly here, see if I can make this work. Wow, interestingly, not many of you knew that Microsoft had a Java engineering group. Well, this is cool. I'm glad we're doing this talk. So how old are these 3 langs? And it's a quiz and there are multiple correct answers, and Java is, actually, that's not going to work. I'm going to exit out of making a poll. That was not a good idea in that system. All right, back to the questions. Okie doke. So how old are these top 3 languages? You will be surprised. Python, which is arguably one of the most popular languages today, thanks to its resurgence with data science and machine learning, is actually a venerable 30 years old. It's even older than Java. JavaScript is actually 24 years old. Not that you would know it, given all of the incredible amounts of churn in things like package management, build systems, TypeScript coming to the fore, new versions of ECMAScript and JavaScript, the language, new ways of doing things, the rise of Node.js, etc. Seems like a very young language, but it's actually been around for ages. And would you believe it? JavaScript and Java are actually the same age. We're celebrating 25 years this year of Java. Some of you will have seen the celebrations going past. And, perhaps this is one of the reasons why recruitment agents get Java and JavaScript mixed up. Who knows? So Java's been around for a long time, as have these other 2 popular languages. And it kind of is a testament to its design and its capacity and capability for running workloads at scale. And traditionally, Java was very good at running workloads at scale when you were vertically scaling. So you could increase your memory, increase your CPU, increase your disk on a single box with your big monolithic application, and you'd get better performance, etc. Now that we're moving to the cloud world, the expectations have changed somewhat. People want to horizontally scale. That means they want to typically run each Java node in a smaller space, right? They want smaller footprint, faster startup time, they want better throughput, and they want steady latency. So they want a latency that they can rely on so they don't get all of these pauses in a chain of microservice calls. So I'll get into that a little bit later. Java is still in the top, been leapfrogged by C in the latest TOB rankings, but at the end of the day, Java is still the #1 business language by quite some way. You can see there that sort of C# is the next really enterprise language as such, and you can see that Java completely dominates that space. Some folks prefer the RedMonk analysis of this. So RedMonk do a really interesting thing. They actually have a look at the questions coming in on Stack Overflow and the popularity of projects and languages on GitHub. And they do a little bit of statistical analysis. And you can see clustered at the top there, JavaScript, Java, Python. There's some interesting things that are going on just behind there out of interest. You can see that C#, PHP, C++ form a little group behind that. And then you go quite a bit further back before you start seeing the languages like C, Objective-C, Swift, Scala, and so forth. This is quite a fun thing to look at every quarter to see the popularity of languages as they head up and down. So yeah, take a look at that screen and see if you can see your most favorite language. So Java still remains relevant. So when you're talking to your colleagues, your managers, your friends, etc., you can rest assured them that Java is still here. It is being modernized, especially when it comes to microservice and cloud workloads. And I'll dive into a little bit of that detail now. So Java is now being released every 6 months. So you get a new major version of Java every 6 months. I hope everyone's now picked up on this fact. This started happening after about Java 11. And there's some curious things that you need to be aware of with this change. It means that if you are a fast mover and you're doing greenfield development and you're confident that you can upgrade your Java every 6 months because you have good CI/CD pipelines and you have good testing, it means you can get the benefits of this new major version of Java every 6 months. And out of the box, especially when it comes to running Java in containers and running on cloud, you will see performance benefits every time you upgrade every 6 months. However, if you are a little bit more risk averse, or if you are deploying at a larger scale, perhaps you don't quite have the CI/CD pipelines in place or the system testing in place, then you're really wanting to look at the long-term service releases. Now, long-term service releases are not an OpenJDK term, so it's not a core term for Java itself. It is really a gentle person's agreement between all of the vendors that every 3 years or every 6 versions of Java, most vendors are designating that as a long-term service release. So that's Java 11, Java 17, which will be coming out next year, then Java 23, Java 29, and so on and so forth. Now, in order to get your LTS releases, you now have a much wider variety of vendors to choose from. If you wish to remain with Oracle and you wish to use the Oracle JDK, it does mean you have to enter a commercial agreement with them. You're picking up a Java subscription, as I like to call it. You can use their OpenJDK for free for 6 months, but if you want to use the Oracle JDK and you want to go beyond effectively the 6 months, then you need to enter a subscription agreement with them. If that is a choice which you can't make for whatever reason, then you have lots of free alternatives out there. So free as in bear and free as in speech. You can look to vendors like Azul, Red Hat, IBM. You can adopt OpenJDK. You can look at the OpenJDK that comes with your Linux distribution, so on and so forth. So there's lots of choice that you can go after. That is probably a topic for another talk in another day. But feel free to ask questions in the chat on that if you have any concerns. Most folks don't realize that Java apps can now be packaged far more tightly. You have these wonderful tools called JLink and JPackage, and I'll dig into those a little bit later on. But you can actually now customize the combined runtime and application for the app that you're deploying. So instead of always having to deploy this massive JVM or this massive JRE or ask your users to have one that's pre-installed, you can actually bundle your app with the runtime elements of Java that you need and deploy that as an executable. And you can either deploy that as a fat jar, or you can deploy that as a native package. So for Windows, an MSI or an EXE, for a Mac, PKG, DMG, and so forth, and for Linux, all of the obvious package manager support there. Java is container aware. Now, there's a little bit of a proviso on this, a little bit of a gotcha. If you are using older versions of Java 8, so anything that's before update 191, you're going to have a bad time. You're going to have to actually explicitly set some variables in your Java command line. You're going to have to do some reading, so on and so forth, in order to use it correctly with Docker. So if you are using Docker, or if you're planning on moving to Docker or containers, then you really need to move to the very latest version of Java 8. For this, I recommend moving to OpenJDK, a version of OpenJDK 8. So again, you have choices with vendors like Azul, Amazon, Adopt, IBM, Red Hat, etc. Move to 8U265 as it stands today, and you'll have all of the Docker support that you may want. When it comes to Java 11 Plus, all your container support is there for free. It just works out of the box, and more often than not, you don't have to make any specific tweaks behind the scenes. You also have some improvements to Java when it comes to running really large heaps, which some of you need to do for big data in particular. Right? So we're starting to see half a terabyte heaps, even larger heaps, believe it or not. It's amazing what you see when you work for a very large cloud vendor. And so there are two really good options, two GCs, which are now available production ready in Java 16. That's ZGC, which is primarily built by Oracle, and Shenandoah, who are primarily backed by Red Hat. Shenandoah, interestingly, has been backported into Java 11, into the mainline, and is actually supported in Java 11 by Red Hat with a bit of support, with a supporting act from ourselves, Microsoft, and a couple of other vendors who are happily using Shenandoah in production. Cool. Right, so that's some of the advancements, and I'm going to dig into those in some more detail. Up the slides here. There we go, that's better. So where is modern Java actually being used? So again, if you were to listen to the tech media is saying, well, you know, we're no longer building these 3-tier monolithic Java apps. We're not building these web apps anymore. So Java is dying, Java is gone. But the reality is Java usage actually continues to grow. It dominates the big data space. So if you're using any of the Apache projects in particular, more often than not, that is a Java or JVM based stack. If you're using something like an in-memory data grid, such as Hazelcast, that again is Java. All of the big tech giants use it incredibly heavily. Amazon, at the very heart of AWS and Amazon.com, it's all Java. Google uses a whole pile of Java internally. Our usage, Microsoft, I'll fill you in a little bit more later, but you can think of properties such as LinkedIn, Yammer, Minecraft, not to mention all of our big data services. It's a whole pile of Java running on Microsoft right there. And of course, microservices have become incredibly popular. And the benefit that Java really brings here is not so much necessarily, you know, the Java language or its programming model, or even, you know, the fact that Java is improving in terms of its size and space when it runs on containers. It's really about developer productivity. So with microservices, for those of you who are building, you know, mission critical applications, it's not always about being able to, hey, connect to a new greenfield document store or NoSQL store and everything's fine and lovely using modern technology. Quite often you're being asked to, hey, can you go connect to that legacy JMS topic over there? Or can you go connect to that ERP system over there? Or, hey, there's this really cool old enterprise library built in Java 6, which no one has a source code for anymore, but we need your microservice to go talk to it. And this is where Java continues to excel, because there is either an open source library or a custom library you can build yourself, which will let you talk to anything, which is just brilliant. So Java continues also to be free with no restrictions. So despite some of the fear, uncertainty, and doubt that was caused and sort of propagated by some, you know, tech media, that Java was no longer free because of changes in the Oracle subscription model or in the change for Java moving to a 6-month release cycle. The reality is Java is still backed by OpenJDK, which is still GPL v2 plus class path exception. And you have lots and lots of vendors who are producing OpenJDK builds, which are free to use. So free as in beer, you don't have to pay for them. There's no field of use restrictions either. So you can free to use them in the way you wish. So if you want to bundle an OpenJDK with your Docker container, as an example, you're totally fine to do that. There's more competition that's come out of all of this. So some of you may have heard about GraalVM as an example, or Azul Zing, or Eclipse OpenJ9. And this is helping fuel innovation inside core OpenJDK as well. So we're seeing lots of awesome new things coming to Hotspot as Oracle and other folks behind OpenJDK respond to some of the competitive tension there, which is great. Of course, if you're a full stack developer, there's plenty going on. A little shout out for Microsoft here. We actually have some pretty decent support for Java and VS Code of all things. So if you're a full stack developer and you're having to, you know, code up a whole bunch of lightweight microservices, and you're finding that you really want that really first class TypeScript support and interaction with containers and things, then surprisingly VS Code is actually a good pick. I'm even using it myself, which surprised me. Next up, I'm going to cover a whole bunch of new features that have come into Java since Java 8, which make it more fun to use with for developers, especially when you're building microservices and you're deploying to clouds. So I'll cover those in a bit. I'm just going to pause for a few seconds here and just see if any questions have popped up. I see Herman has popped up with a chat commenting that he was running his first Java course in 1994. So At the moment, he is winning the oldest Java course out of the group. I'd love to hear from other people when they first started using Java. So do pop your comments away in the chat. Be good to hear. Without any direct questions at this stage, I shall continue. So, developer productivity. For those of you who missed it, in Java 10, we now have local variable type inference, which is a long mouthful way of saying you can now, on the left-hand side of your declaration, instead of putting Java's static type, you can just put in the keyword var for variable. And you can use this when on the right-hand side, Java can infer what the type is. And ever since Java included things like the diamond operator and started enhancing its capability for type inference on the right-hand side of assignments and when dealing with lambdas and things, it's now become possible to understand the static type of what is going to arrive into your variable. And the key thing about using var, and I do caution that you should not just use var everywhere. Sometimes it is better for readability and for the developer coming in after you to understand what they're working with, is to put in the static type. But the very cool thing about this really, and I was speaking to Brian Gertz about this, who's the Java language architect, is really that your business domain actually starts to come out in your source code more. So typically with verbose Java, when you're declaring that static type everywhere across your source code, it tends to dominate the screen a little bit, right? And so when you're reading your code, you're having to filter out in your brain what all these static types are to try and read the variable names and understand the business logic just that little bit better. When you're using the shortened var keyword, that's exactly what happens. Combined with good variable names. And when I say good variable names, it does not mean using a single letter, as I have proclaimed in other talks I've done as a diabolical developer. If you have well-named variables, then the business logic, the logic of your domain really starts to come out. And that's really the actual hidden benefit of using var here today. We have text blocks, finally. So for those of you who are working in XML, JSON, YAML, yes, YAML, or Markdown, or any of these other markup languages, HTML is here as an example, of course, you can now display that in your source code with a text block. Some of you will call this a multi-line string. It took a couple of versions of Java to sort of bed this in and iron out all the little kinks, because you've got string interpolation and all sorts of stuff that can happen. But you can see here, you can use a triple quote. You can actually lay out your markup language inside your Java code and have much increased readability. So this is a very cool new feature that's coming. So Java 14 onwards, folks. Continuing the developer productivity theme, we now have switching expressions. This came in starting in Java 12 and it was enhanced in 13 and 14. And you can see here some interesting things. So you can now switch on an expression as opposed to just switching on a const. And you can now actually have some logic in your case blocks. So you can see there in the default case, I've actually added some actual genuine logic there. Note the terrible use of a single character as a variable name for the string. And you'll see there the yields keyword is being used to return the result in the default case. But this is really fun because you now start to switch on more complicated data structures, right? So it really does enable the developer to have more flexibility in switching on a much more complex construct than just the primitive types that we had before. And at long last, we have records. So some of you will think of this as tuples. Some of you will call this all sorts of different names under the computer science vernacular. But really what this is about is being able to deal with data types or deal with data in a way where you do not have to have the overhead of a full Java object. So for those of you who don't know under the hood, every time you have a Java object, the Java object has to have a header. That Java object has to have, a header has to have space. And there's a whole lot of extra under the hoods JVM performance implications of having a Java object. It impacts garbage collection, it impacts the graphs of how the just-in-time compiler takes a look at the sea of nodes, a whole bunch of other stuff when stuff gets executed. So being able to actually define a data structure, such as the point here, without the overhead, and these are immutable data structures as well, so you get that immutability at last, is going to be really powerful, especially for anyone who's doing any sort of machine learning work, graphics work, or who just wants to represent some real mathematics or real objects in the real world. So these are all going to be tightly packed. From Java 15 onwards, there's going to be more under the hoods performance improvements made to these. And that'll ensure that when you use these, it'll be packed really efficiently, and you'll be able to use all that. So this is a really, really big boost to Java. And if you're using this type of data today, I highly recommend you take a look at Java 14 and onwards. Thanks to Gertz from SAP, we now also have more helpful null pointer exceptions. So finally, when you have a chain of method calls and you're not sure which one of those was causing the MPE, the stack trace will now tell you. This actually took a lot more VM engineering under the hood than we first anticipated, but it was well worth the wait. And this is now done in a good performant manner as well. Hopefully everyone's familiar with the fact that we now can have default implementations and interfaces. But as a reminder for folks, the reason why this is so important is because you can now do more inheritance by composition. And in turn, this gives you far more flexibility when you are designing your APIs and microservices. So it really is sort of an architectural pattern that I would encourage most of you to dig into further. And one other strange new enhancement that's come in, a port for Windows ARM. This is what Microsoft has been working on. This is what my group has been working on. It just landed last week in Java posted for Java 16. So if you are running Windows on ARM, and shortly if you're going to be running the new Apple Silicon, we're working on that as well, then that's a new port which Java is now working on. So that's pretty exciting. So joining its friend on Linux ARM, we will have Windows and Mac ARM. And if anyone wants to try it out, I've just popped the URL in there as well. I'm going to pause there and see if there are any further questions. I'm seeing people here, Java 1998, 1997, Java 1.12, nice. Is GraalVM ready for production? I will cover that in the microservices section where we talk about a couple of microservices frameworks that use GraalVM. And I'll tell you the positives and the negatives of it from my personal perspective and also a little bit how Microsoft sees this today. I'll just check the questions. Okay, so the question pops up in the chat. That's good. Okay. Let's get into smaller and lighter Java for cloud. So Java can now be packed much more tightly. So this is excluding GraalVM. So even just ordinary OpenJDK Java, you can actually bundle this thing up and really tightly package it. David Delabisi there, who actually works for Oracle, but that's neither here nor there. He shows an example here of using a couple of the compression flags, picking out the specific modules that he needs for his application, and taking a runtime size from 360 meg all the way down to 34. So again, you can use the two tools of JLink and JPackage together to build these really lovely little customized applications or services, which you can then deploy either to customer desktops or to a VM or to a Docker container. You can build a Docker image with the minimal support for that as well. It takes a little bit of work to use JLink and JPackage to begin with, and I would argue that the command line tools are pretty darn good, but there's not a huge amount of support yet in, say, the IDEs or any sort of GUI support for this kind of stuff. At Adopt OpenJDK, we're actually building a tool called JLink Online, which will help you just automatically use the JLink tool through a web-based GUI there. So do go check that out. You can find it at github.com/adopt OpenJDK and just search for the JLink repo. Java is now lighter, of course. It's been deduplicating strings for quite some time. If you're using the G1 garbage collector in particular, and you're a heavy XML, JSON, or Markdown user, and you're basically processing that in Java and spitting it back out again, then we have deduplication. So you'll actually, you should see a benefit there in terms of reduced heap usage, which is pretty important. This class and application data sharing. What this basically means is that when your JVM first starts up, it can save off the classes that it loads up as part of the JVM. It can save off the core metadata when the application starts up, saves that off in a file, and when you fire up the JVM the next time around, it kind of can preload from that cache effectively, right? We also have a ahead of time compiler inside Java, which most people aren't aware of. And so, if you're migrating, say, to Java 14.15, you'll see a startup improvement out of the box over the top of Java 8. Now, if you want to go extreme on startup times, then you probably still need to look at something like GraalVM. But I'll cover that in the GraalVM section. Okay, obviously Java continues to give you performance gains out of the box. I mentioned before it was container aware, but every time you upgrade a Java version, that awareness gets better and better. So it starts to look at things like the CPU share allocation. It understands all of the latest telemetry and information that the container will give you, and that allows you to have more fine-grained control of what's going on in there. Interestingly, there is a new garbage collector called Epsilon, which is by Alexei Shitilev of Red Hat. It's a no-op garbage collector. So if you're running a serverless microservice, and basically, you expect your Java service to fire up, do some work, and then disappear again fairly quickly, you don't want any pauses at all from garbage collection, then you might be able to choose the no-op garbage collector, which is quite fun. And you can see there that you can follow the projects with all the cool names up in OpenJDK to see all of the new stuff that's coming in as well. So we're getting lightweight threads through Project Loom. We're getting faster native interop through Project Panama. We're getting more efficient data types through Project Valhalla. And to effectively bring some of the benefits of GraalVM to OpenJDK Core, Project Leiden is just been started up, and we're hopeful that will bring a lot of the similar benefits that GraalVM brings you today, without having to port your apps across to the native image format. Alrighty, so when you're moving to cloud, you're typically wanting to build microservices when you're greenfielding. You may be lifting and shifting your monolithic apps as well. That's a talk for another day. But I'll just focus on your microservice choices as they stand today. And things have changed a little bit in the past year. Everyone is probably familiar with Spring Boot. Depending on which survey you look at, it runs from anything between 30 and 60% of the Java market in terms of microservices that are built today. It's obviously very familiar to those of you who are using Spring as a framework previously. Word of caution, Spring Boot, much like the Grails of old or the Ruby of Rails of old, is brilliant if you are building fairly simple services. But as soon as you want to do anything more complicated and sort of go outside of the path that Spring Boot wants you to go down, you can find yourself in trouble, right? Once you start having to do workarounds and you're coding, side little bits to the side and things like that, you probably want to stop and think and ask yourself if Spring Boot is really the right choice at that point going forward. For those of you who are interested in producing the Docker images with Spring Boot, you can follow Belding's guide there. Spring Boot with Docker, this is what it tends to look like. So thanks to Chris Richardson, who's a fellow Java champion, for sort of demonstrating there about how you run Spring Boot in a container. This is just a very, very quick example of the sort of Docker level configuration you would need to set. So you can see that he's done the port mapping there. He's gone and he's passing in a couple of environment variables for this particular Spring Boot app to talk to the right MongoDB in this case, and a RabbitMQ host, so on and so forth. So you can see how these concepts map across. For those of you who have not really developed with Docker or dare I say it, Kubernetes before, It's this kind of configuration stuff which is the biggest pain point, right? Understanding how to map the Java thing that's running inside the container to the outside world is going to be probably your biggest challenge. And what I've personally found helpful is to really draw that out on a whiteboard or on a piece of paper and say, right, I want to have an HTTP request to get to my Java app. How do I cross the Docker container boundary in order to do that? And if you're adding Kubernetes to the mix, you have to ask yourself, how am I going to cross the Kubernetes, the pod boundary to get to the Docker container, then to get through to Java app, right? And if you can clearly answer those questions, diagrammatically, and then in the configuration as code, you're going to have a much better time of it. But I appreciate it can be frustrating to start with. One small extra tip that I like to give people who are new to this environment is temporarily do enable SSH inside your Docker container so you can get inside and continue to be familiar with having some command line access to your Java that's running inside that container. And once you really understand, where port flows are going, where log files should be going, and again, remember you're trying to stream all of that stuff off the container if possible. Then you can, later on in production or in tests, switch off that SSH access because that's a security vulnerability waiting to happen, and just run the Docker container nicely isolated by itself. Microprofile is a multi-vendor effort at providing a standards or standards body-like environment for people who were formerly Java EE or who are Java EE developers today. So if you're comfortable using things like CDI, JAX-RS, JAX-WS, all those kind of technologies, but you want to build microservices, then Microprofile is really the choice for you. All of the vendors such as IBM, Red Hat, Payara, Sun, and Oracle themselves have all got implementations, so runtime containers that can run Microprofile apps. And they follow the 12-factor app philosophy, so you've got lots of microservice philosophy, so you've got lots of things like health checks and circuit breakers and all that good stuff. We have Quarkus. So this is where I start talking a little bit about GraalVM. So GraalVM is at production ready. Yes, but you have to remember that GraalVM is split into two. One is a community edition and one is the paid for enterprise edition. If you really want all the bells and whistles and the ability to debug, like have debug symbols as an example, and have the better performance benefits, etc., you're going to have to pay Oracle some money and pay for an enterprise license. So it's kind of let the buyer beware here a little bit, that the GraalVM community edition is kind of the lesser citizen of the two. And because it's not backed by a software foundation and it's controlled by a single vendor, you just have to take that into account. I'm not saying it's a good or a bad thing. It's just something you need to be aware of going forward. Another challenge with GraalVM is its native image format. So this has been touted as the new wonderful thing for microservices in Java. You get this fast start time, this tiny footprints, so on and so forth. The challenge really here is that you actually have to modify your applications or your application stack in order to be native image compatible. So native image can't do things like deal with reflection very well, as an example. And so when you look at frameworks like Micronaut and Quarkus, what they've actually done behind the scenes is they've gone and modified a whole bunch of libraries that you were used to using in the Java EE days. So again, JAX-RS, CDI, all those things. And they've modified them so that they can work in the native image format. And you would have to do the same thing with your application code, potentially, depending on what features you've built into your application code. That can be a non-trivial, expensive rewrite of your application in order to be able to take advantage of this native image format. Now, GraalVM always allows you to go back to just using, straight old Java, plain Java interoperability, so to speak. But then you lose the performance benefit of that native image. And so you might as well just use OpenJDK at that point. So I would research and pick carefully whether or not a GraalVM-based framework like Quarkus or Micronaut is the right one for you. I always remind people, check your non-functional requirements when it comes to selecting these frameworks. Arguably, and I've tried them all, not hugely in anger, but I've tried them all with some reasonable size apps, and I found all of them had decent developer productivity. I was able to get up and running quickly with quick starts. I was able to deploy to containers and my cloud of choice and all that good stuff. But when I really started to dig into things like the monitoring, the telemetry, distributed tracing, all that kind of stuff, that's when the maturity of some of them were better than others. And it's a constantly evolving, constantly changing state. So every quarter, because things like Quarkus and Microprofile are releasing so often, you're getting a different version of those that you need to go and evaluate. So do take a look at that stuff carefully. And of course, your cloud choice, all three major cloud providers support Java really well. So that's Amazon AWS, Microsoft Azure, and Google's GCP. There are other clouds, of course, but those are the three completely dominant players at this stage. And we'll see if the other cloud vendors catch up in that space. Here's my marketing slides. I work for Microsoft now, so I'm obliged to put this slide in. There is a URL if you want to learn more about all of the Java that you can run on Azure today. We're at the 40-minute mark. So at this point, I would normally stop the presentation and get into Q&A, but I'll just very quickly go through Microsoft's investment in Java, and I'll skip the marketing stuff at the end since this is a developer conference. So a bunch of people have asked, what on earth is Microsoft doing with Java? I'll go through this quickly. So we actually use Java really, really heavily. So again, we're a major cloud vendor here. We have LinkedIn, we have Azure, you know of Minecraft, Yammer, and we have lots and lots of developers who use Android. So surprisingly, Microsoft is probably one of the heaviest Java users in the world, which is surprising to me. Especially as of starting last year when jClarity got acquired, Microsoft is now giving a lot more back to Java. And this has been a learning experience for all of us as we join various open source and Java communities. But you've seen us donate back to OpenJDK with the Windows ARM port as an example. We are one of the core sponsors behind Adopt OpenJDK, and we're on the steering committee there. So we're helping ensure that the Java ecosystem at large has a free Java as in bear and a free Java as in field of use, pretty much for life, where we really want to back that for the next 10, 15 years and make sure that folks always have that choice. We'll skip this. That's kind of markety stuff, really. Azure Spring Clouds. As I mentioned before, Visual Studio Code. If you're interested in writing Java microservices, then you may want to take a look at that. Obviously, we own GitHub as such, although they're a subsidiary who definitely run things their own way. But there's an interesting take there on code spaces where you can run Java on their server side effectively and get all the GitHub benefits from that. And for a lot of you who are using Windows today as on the desktop, and you're having to write your Java applications, but there's a whole bunch of Linux specifics to the Java application that you're writing because you're typically deploying to Linux. You might find it useful now that you can use the Windows subsystem for Linux in order to run that Java app or even develop that Java app in WSL. And if you have those, Linux specific libraries and Linux specific calls that you need to test, hopefully you can now do that on your developer desktop. And with that, I will run through to the conclusion and skip the marketing slides. There we go. So Java's core has been modernized. It is now actually more than capable of running a cloud. You do have to do a little bit of work, though. If you really want that small, tightly packed Java, you can either use things like JLink and JPackage together, or you can pick a framework like Micronaut or Quarkus if that's really of concern. But do take care when you're picking those. You only really want to pick those if you have the genuine use case that you need fast startup time, which is actually often not as often the case as people make out. And you want to make sure that your application can actually easily fit into that native image format if you need to. Obviously, pick your cloud carefully. There's really this year, 2020, really is a year of evaluating carefully, right? You're going to be making choices this year which will stick with you for quite some time. And so doing some really careful evaluation of all the different frameworks out there and the version of Java you want to use is going to be pretty critical. So I'll stop there. There again is our Twitter handle and a link to our Java blog. And I'll just pop across now to have a look at the questions that have come in the meantime. So do feel free to fire in more questions. The results of the poll was interesting. So, wow, only about a third of you knew that Java Microsoft had a Java engineering group. So obviously more for us to do to let the word out. So the main question I still have here is about Graal VM. So some more interesting info here. So even for Quarkus, Red Hat themselves are trying to put a layer in between themselves and the dependency on Graal VM Community Edition. So they've actually started a new open source project as a layer in between to try and dampen down some of the core reliance on Graal Community Edition there. And I think that's probably just a response to the fact that Graal itself is not currently in a software foundation where it sort of has a more open development model, such as like OpenJDK has. And so we'll be watching the space with interest. If you took a look at the recent InfoQ reports on where they see industry trends moving, they sort of have put Graal VM and Quarkus on the evaluate stage. In sort of the software development lifecycle. So if you're greenfielding a new project, then it's definitely something you should go and evaluate. But you should take some care and really think about how long are you going to be needing to support this particular piece of software for, this microservice for. If Graal VM does not turn out to be a long-term player in the Java ecosystem, you need to make sure that you're not building, 100,000 line Java applications on top of it at this stage. Maybe 2021 will be different. Cool. Are there any other questions? Do pop them into the chat on Skype.
Okay, well, thank you very much for that, Martijn. That was really interesting look at Java and Microsoft as well. Obviously, we don't have the live conference here, but if anyone wants to show their appreciation, like Anton in the chat there, then that would be really appreciated, because that's something that we miss, is the interaction with the audience, I think, in this remote setup.
Oh, all right. Well, thanks again, everyone. And I hope you enjoy the rest of Virtual JAX London. There's loads of other talks, by the way, which are going to dive into technical detail on running Java on containers, Kubernetes, and Graal VM, and some of the frameworks I mentioned. So if you consider my talk as a bit of an overview talk, then there's plenty of others where you can deep dive into the ones that you want to have a look at.
Right, thanks very much, Martijn. I think we're having a short break for lunch now, and then JAX London 2020 goes further later on this afternoon. All right. Thank you very much then.